Okay, so this is an epoxide. How do we take an epoxide back to a starting reagent that we can work with?
Use the MC.
MCPBA. So what does that take us back to? An alkene. So, what is the stereochemistry for this alkene going to look like?
I mean, like
What goes
The
with each other?
the H's.
Hydrogens go together. And what else?
The CH3 goes on the bottom, on the right.
Yes.
And
CH3.
that's
Oh, CH3.
on the right side.
Yeah. And then you have
What is
C2, C3.
CH2, CH2.
Yeah. They're all C already.
And it looks like we also have this.
From your right hand, C2, C3.
This?
Yeah, the C2, C3.
Oh, yeah.
Oh, I thought it was a methyl.
Yeah, no, this is also another carbon, right? Okay, so how do we take this back to something that we know? How do we, well, I guess I should mention what y'all can start with.
Oh wait, where did you bring from?
Oh, we haven't broken any bonds yet. All we did is change the alkene to an alkoxide using MCPPA.
Oh.
And we just basically retain the stereochemistry so the H's go together and the other groups go together. So alkenes, alkynes, slash alcohols of 3 carbons or less. Okay, so we have to break this apart somehow, right? If we have to get down to 3 carbons. How do we make a cis alkene?
Oh, it's the H2 something.
H2, okay.
H2PD.
H2PD.
That's it.
Is that the quin?
Quinoline.
Oh, quinoline.
Basically, and BASF. Make sure you get the quinoline in there.
All 4 of them?
You can write H2 Lindlar's catalyst. So, I'm gonna erase this. H2 slash Lindlar's. That basically includes everything else. So, what does this, what do you take to turn into a cis alkene? What reagent, what compound do you use H2 Lindlar's with? Triple bond, an alkyne.
And that gets rid of the H's.
Because this is partly a reducing agent, right? So this is how the H's get on there in the first place. So we have this carbon, this CH2, CH3, CH2, CH3, and write this OH line. Now, is there a way we can break this molecule apart?
Yes.
Where?
Split it at the alkyne, right?
Split it at the alkyne. So, you want to split it here? Right? Because what can we turn this into?
A Grignard
Oh.
Carbonyl.
Carbonyl. You can either use a Grignard or an alkyne to add carbons onto a molecule. So in this case, since we're using an alkyne, we don't need a Grignard reagent, right? So this part will just be, I wish we had more room down here. So what step is written here? Plus a carbonyl. What kind of carbonyl is this? Is it a ketone or aldehyde?
Ketone.
It's a ketone. Right? Because it's attached to this and to this ethyl group. So there's two ethyl groups.
What makes it an aldehyde?
What makes it an aldehyde? If it's only attached to one, then it has to be an aldehyde because you want to add the right number of carbons on there, right? So say this was actually an H, then you would want to add an aldehyde rather than a ketone. So it's all about how many carbons you want in your final product and how many carbons that carbon that's attached to the OH has. So what step should be written right here?
MH3.
Same as Grignard, right? After every Grignard, basically after every carbon-carbon bond formation, you want then H3O plus. Okay. So, do you want to start with the left side or the right side? You have to make both of those, so.
Carbonyl.
Carbonyl? Okay, we can start here. How do we turn this into something that we know?
PCC.
How many?
Yeah.
Yes,
PCC. Yeah.
What does this take us back to?
Alcohol.
Yes. You only want to make an alcohol because like from the alcohol you can do Grignard, right? Yeah. So if you have a long chain, and like you have a carbonyl, you want to turn it back to alcohol.
So because we have a 5-carbon chain and we need to get it down to a 3-carbon chain, we have to do more carbon-carbon bond formation. So what reagent do y'all want to use to accomplish that? We have organolithium, Grignard, carbon, alkyne formation. Grignard? Okay.
Is there ever a time where you need to be specific?
No.
Or does you just
Well, in this case, it was easier to start with an alkyne, right? Alkyne formation because you had
You already
to get
had, yeah.
cis-alkene, right? That
Okay.
stereochemistry does matter. And if you had formed just any alkene, there could be a chance that it would form a transalkene, which is not what you want, right? In your final product. So there are opportunities where you can lose points because of that. So in this case, the alkyne bond formation would have been easiest. But here, it's easier to do Grignard. So it's just whatever you can think of and like whatever pathway you can like formulate in your head. So if we decide to go with Grignard,
Split it on
where do you want to
either
split
side
it?
of the CH.
This side?
Yeah.
Okay, we can split it there. So what kind of carbonyl is this?
Aldehyde.
Aldehyde. Right? If we split it here, the carbon that's attached to an OH is only attached to one other carbon, right? The other side is attached to an H, so it has to be an aldehyde. Does that make sense? So the Grignard portion then would be MgBr CH2 CH3. And what goes right here?
Then H2O plus. H3O plus.
An H3 plus. I'm going to use this stand because I'm short. Don't laugh at me. How do we take this back to one of those options up there?
PCC.
PCC. CH2. it's up there for this one because
CA.
it's less than 3 or less. How do we form this?
Mg and ether.
There are a couple ways to do this. How do you want to add the Br on there?
PBr3.
Yeah, we can do PBr3. You could have also done Br2 in light because it's,
Oh, that's so much easier.
but then don't
And
forget the excess.
Yeah.
Oh yeah.
But if we want to use
An alcohol.
an alcohol, we can do that also. And there's no excess for this one.
Yeah. On way, you cannot use alcohol. That's that material. So PPR3 is really powerful.
Oh yeah, so
Yes.
we can't start with an alkane either, so you would have to turn that into an alkene anyway, so
Oh.
that wouldn't have been.
Wait for what?
Because the starting reagent asks for alkene, alkyne, or alcohol, no alkanes.
Yeah.
Oh, okay. So you wouldn't.
Yeah,
have
so
done
so Br2 in this case you would have had to
Okay.
take it even farther back.
But I mean, I just realized that it wouldn't have even added because the Br is at the edge.
Well, yeah, but there's only 2 carbons,
Oh.
so in this case it won't matter. Yeah, but
So use PBR3.
so now we've made this side. Now let's go ahead and make the alkyne side. How many carbons do we have here in this alkyne?
4.
4. Can we start with 4? No, what does that mean?
To break it.
We have to break it. So, how can we break this? Well, first, we have to deprotonate this somehow because we can't have 2 sides.
So would it be Na?
Yeah,
NaH2?
We can't have something like this because this is not stable. So you have to deprotonate this. You have to deprotonate this side first, and then break it right here. Right. So you can only have a charged carbanion on one side, not both.
Could you do ozonolysis and like,
Well, how
is that a thing?
we can do ozonolysis.
Or like Grignard?
But what would be an easier option here if you wanted to break it right here?
Grignard?
Not green yet.
No, not Grignard. We can do
Oh,
alkyne
it's a-
formation, right?
It's a triple.
Triple bond, so okay. We can do something like this. This is a good nucleophile, right? What could be on this side in order to accomplish an SN2 reaction? Br, a good leaving group. Right? This will just be SN2, basically.
Oh.
Oh, okay.
Do we need to do anything else? Or
Do
is
you have
that-
to draw the 2 lone pairs on there as well?
Oh, well, I mean, not really. As long
because
as you,
it has the negative.
as long as you indicate the negative or the. I didn't even draw this right. Okay, so if you can see, if you have an alkyne and you need to break it down, just use the alkyne method. Don't go back to like a Grignard because then you have more steps.
Mhm.
But it's doable, but requires more steps.
Okay.
Do you
So
have to put heat over the arrow?
no. This will just happen because this is an
Oh.
SN2, right?
Have an SN2.
Oh, okay.
You have a strong base and
And a
a
good
good highlight.
leaving group.
So, that alkyne, is that like a, oh, okay.
Yeah, you have to go one step
Yeah.
further.
So yeah, we have to go one step further, right? We can't have it start with a charged
Yeah,
molecule.
so Na,
NA should. Again, because all we need to do is deprotonate it in the step to get that, right? So how do we make this?
Do we need to make it?
PBR.
we've already.
Oh,
Yeah,
yeah, you're
we
right. We already made it. So all you have to do is really Well, actually, you can just leave it blank.
You don't have to do anything.
Because we already made this, right? We already made it up there, so you
So we don't have to like draw
no.
the arrow.
Okay.
You can stop there. Wow, this is a long one. Any questions?
Okay.
Um,